This MOOPIL series of Texas A&M University is provided through Project LISTO. Literacy-infused science using technology innovation opportunities. The video series is comprised of experts in the field talking about their research while making important contributions to the art of teaching in the K-12 environment. Project LISTO is funded through a competitive I-3 grant from the U.S. Department of Education Investing in Innovation program. The LISTO project is a collaboration among the Center for Research and Development in Dual Language and Literacy Acquisition, Education Leadership Research Center, and Aggie STEM.
Hi, my name is Andrea Burrows, and I'm an Associate Professor of Science Education at the University of Wyoming. And I'd like to take a couple of minutes today and talk to you about the integration of computer science into science and into other disciplinary areas. For example, one of the things that we talk about is that a lot of people think computer science is coding, and it's not. Coding is a tool that computer scientists use, and it might be an end goal for a lot of people, but it is not computer science. So one of the things that we work with our teachers is to talk about puzzles and solving problems and how that relates to computer science. So if a teacher has any sort of problem solving in their classroom and they have students going through any sort of logical steps, then chances are they're on their way already to talking about computer science, and they just don't realize it. So we talk about patterns and pattern detection. We talk about how this comes up in anomaly detection in engineering programs. And we talk about machine learning and how in machine learning you're trying to get a computer or a machine to think like a person. In order to do that, there are certain logical steps that are written down. And in science class, in labs, oftentimes there's many steps that are written down. And that is an algorithm. So we talk to teachers about making that explicit for students. In terms of distances, if there are very large distances, then that is something else that teachers can talk about. They can talk about dimensions, 2 to 3 different dimensions with those distances, and that is a part of computer science. We also talk about virtual reality, and we talk about gathering information. So you're talking about different dimensions, you're talking about patterns, you're talking about detection of the world around you and context, and you're talking about modeling. And again, all of those pieces are pieces of computer science. So computer science can be integrated into any science classroom, K through 12. We have kindergarten teachers that will do a lesson that they've done for many years on pattern detection with students. Maybe they're looking at popsicle sticks and they're picking out all the ones that have red circles. But in addition to that, now they can point out that that's the beginning of computer science, and they can use that terminology with their students. We have middle school teachers that are using different forms of solving problems with weather prediction, and again making it explicit that that can be connected back to computer science. And then we have high school teachers that are working with creating models for classes or using NetLogo and coming up with ideas for a future type of model, and again connecting that back with computer science. So regardless of the content that's being taught, there are pieces that can be pulled out of what's being taught and then made explicit connections to computer science. So the other thing that we hear is that, well, there has to be math involved. So I don't teach a math class. And one of the things that we say is, yes, there is math involved, but that math is at the level that the teacher wants it to be. And then when they're using that, they're able to connect what they're doing with the content piece and then connecting that back to patterns or connecting that back to system modeling. So there is math involved, but it isn't necessarily complex or complicated math. And in addition to that, there are many examples in the curriculum and in the content in terms of anytime something, again, has to follow a series of steps. anytime that someone is looking for the solution to a problem, that's easily connected back to computer science. In biology, all of the different systems that we talk about in terms of like metamorphosis, that would be just one small area that a teacher could use the content that they're teaching to connect back to an algorithm and thinking in logical step-by-step progressions. And at this point, notice we haven't talked about coding in particular, because students, even being introduced to the concept of computer science, might take a standalone computer science later on in their careers, but in the beginning just need to know that it exists, and it exists in all these different disciplines. Of course, computer science has connections to robotics, and a lot of times we hear connections to robotics first. And for some students that's fantastic, but for a lot of students that seems distant from what they do in their day-to-day lives. So finding something that connects with the students and something that they have an interaction with on a daily basis or a frequent basis is a much easier place to start for the student to see those connections. Sometimes that might be robotics, but sometimes it might not. And so a caution to teachers is just to keep that in mind when you're working with your students. And as always, know your students and make sure you're using what's best for them. And then there's always the standards discussion. Are we using next generation science standards? Are we using state standards, Common Core, ISTE, the list goes on. And what we talk with and try to get teachers to do is to interact with those standards in a way that they are meeting their content standards, but introducing computer science standards as well. So some states have computer science standards in place. Other states, like Wyoming, are in the process of creating them. And then some states don't have them in place at all. So in the next generation science standards, there are science and engineering practices. And looking at what you could do with computer science is just one way that you can get at those science and engineering practices. So again, the patterns, the cross-cutting concepts that they talk about, the systems, the system modeling, the cause and effect, all of those pieces tie back into computer science. And it's often a misconception that teachers have that they aren't doing anything with computer science. And so one of the things that the message we're trying to get out there is that these pieces are integrated. Computer science is integrated with different disciplines, and regardless of the level, K-12, that can be pulled out and made explicit to students. So there are definitely areas where teachers can get help, schools can get help. For example, TEALS, the Technology Education and Literacy in Schools program, sponsored by Microsoft, they can help in terms of getting engineers working with teachers in classrooms. There are other examples as well. And one of the things that we've been using this past year, which is low cost, about $15, and it is easy to manipulate, is a microbit. And a microbit is a computing device. It's a microcontroller, and it has Bluetooth and an accelerometer. It has 3 axes, a temperature sensor, a light sensor, LED matrix, 5x5, 2-button input, and capacitive touch inputs as well. So our teachers, K through 12 this summer, tried to come up with ideas to integrate those particular microbits into their content areas and how they would use those to help the students help infuse that computer science piece into their content. So they're in the process right now of doing some of that work. In the past, we've used Arduinos and Raspberry Pis, and I try to make it clear that we are not sold on any particular technology, that the technology is just, again, a tool that we're using to help students. But one of the things that we have are quite a few Flipgrid videos from our teachers showcasing things that they want to do and showcasing things that they've already done with their students, hopefully to get other teachers thinking about things that they could do in their classroom. Because I am a champion of teachers who believes that they're doing more than they realize they're doing in the realm of computer science. In addition to that, we worked with a couple of camps this summer, Gen Cyber camps, and those Gen Cyber camps were focused on cybersecurity. Again, we used the microbit, and we had students working on a couple of different projects. We had a beacon project, a lockpick project, a fitness tracker project, and a microbot project. And so if a teacher was interested in incorporating cybersecurity as a piece of a lesson that they were doing, for example, a biology teacher might be talking about the security of a DNA chain. If that's the case, then they might be able to use one of these particular lessons to reinforce that idea or that concept. There are many different examples of teachers using these types of projects in all kinds of STEM classrooms, particularly in science education. We are excited about the idea of hopefully getting teachers on board with embracing the computer science piece that they're doing in their classrooms. So our messages are two very small, short messages. One is think integration, and two is think simplicity. Don't think coding, and don't necessarily think complex. So integration and simplicity, and the coding piece will come. Microbit, by the way, does have online capabilities of programming. You don't need to download any software, and as long as you have an internet connection, you can use that. It's free. So with that $15 device, you could have students sit down at the computer and begin drag and drop coding. They can also switch that over to see the programming language as well. If we can help you get started using computer science in your STEM classroom, you're welcome to contact us. My name again is Andrea Burrows, and I work closely with Mike Brofchek in the computer science department at the University of Wyoming. And we're always interested in helping teachers integrate and to make their content more robust. One of the things that we might ask is where you think that you would need help teaching in general, like what lesson or what unit or what area of the year do you tend to try to struggle to find content to talk about or projects to do or activities. And that's the area where we usually start, and we try to find some computer science components to fit in to help you supplement that particular area. So thank you very much, and I appreciate you listening.